In this fast track, we will see what Java streams are. Java streams enable us to efficiently apply operations to a data source. Data sources can vary: array, collection, input, output channel, etc. From this particular data source, we create an instance of a stream, enabling us to execute various operations within the stream context. Two main types of operations: intermediate and final. Data manipulation involves filtering, sorting, and mapping. And in the final steps of the process, we are able to take one last crucial action with this dataset, such as summarizing its contents, performing counts, or transforming and aggregating the data into a different format or list. This helps to streamline and consolidate the information for further analysis. Brief example provided. We have a list of numbers, a list that is a collection of integers, which we convert into a stream. Filter this stream, we get nothing. We filter this stream, we get only the even numbers, and convert those integers to integers, from integer to int, to the primitive. And as the final step, to complete the operation, we sum all the integers. The primary aim of a stream. And in the end, I can print the final sum. What is the difference between a stream and a collection? Avoid confusion. Various collections include lists, sets, maps, etc. In a stream, we have operations like filtering, mapping elements to match between two elements, transforming data, and more to process the data efficiently. Essentially, a stream is typically generated from a collection and primarily functions to execute operations on the data elements within it. Streams work in a lazy manner, meaning that information is only provided when requested, whereas collections work in an eager manner, meaning that the data is always actively cached and ready for immediate access. This difference in behavior impacts how resources are utilized and processed within the program. In the collection, I can add and remove elements. In streams, I cannot. Streams are read-only. The stream can only be traversed once, but in the collection, I have the flexibility to traverse it multiple times if needed. The main distinctions between a collection and a stream are as follows. Let's see another example. We have here a detailed list of names of type string. So here I have two different ways to execute a stream. I can typically accomplish this task using either the stream method from my list or the parallel stream method for parallel processing. What is the difference? That parallel stream will run in parallel, meaning there will be multiple threads simultaneously filtering the information in this case, which can improve performance and efficiency. When using one or the other, well, if you want to make a faster execution, use parallel stream, but you must consider that for the stream it will not necessarily respect the order of the information. On the other hand, the stream does respect the order, but obviously the execution will be a bit slower. Here I am filtering the elements, applying a lambda operation where I say that I only want the elements whose size is greater than 5. I apply an intermediate operation called skip, which is purely from the stream as well as filter. Skip is an intermediate operation that will skip the first two elements in the stream. A terminal operation, such as for each, is then used to iterate over the remaining elements. For each applies a consumer, a functional interface, to print the content of the stream. The skipped elements are excluded from the final output. It is finally what this operation does for us all. Here are different types of operations with streams. Some are intermediate, allowing for further operations after filtering, mapping, distinct, sorted, limit, and skip. Final operations like for each, to arrive, reduce, min, max, count, etc., can then be applied to process the stream further. So it must be taken into account